right, kids, we'll get here started in just a second. Give me 1 minute. So let's get rolling, everybody, and welcome to the stream. Thanks for coming out and joining me today. We'll get into some tuning stuff and just general Q&A. Before I do that, I do need to get this chat thing set up. So let me hop out of here. Hop out chat. Grab the link. And then throw that into here. And there we go. Kaboom. It works. There we got to go that way. That way a little bit. Then my, oh, what's wrong? Lighting. Yo, there we go, buddy. There we go. Amazing how that works. Yes, welcome to this semi-beautiful Sunday here where I live, at least. It was sunny this morning. It's a little cold today, but it'll get warmed up. Welcome to the stream. As always, my name is Mark Spatz, and feel free to drop any questions down in the comment box down below. Try to help you with your specific issues on your drones if you're having any, or if you want any help on doing some tuning, you can either throw a link down in the description down there, this way, and I'll be able to pull that up, download it, and take a look at it specifically. If you have access to Discord, you can throw your stuff here in this office hours or into the general chat up here. I guess the office hours is for patrons, so I'll be hopping over there to take a look at some of the patron stuff that we have here. And but otherwise, feel free to hop into Discord and then just go into the general hat or general help or chat or general tuning, whichever one fancies you, and just you can tag me for it. There's this help forum up here as well, so you can click into that and then make a new post in that as well. So that whichever way, just make sure to tag me. Just put at UAV Tech, and then I'll see that come up here as we're going through the stream. So I guess without further ado, let's just get into it. If I see questions down there in the chat box, I will go ahead and jump onto those. We do have some office hour stuff here, so let's look at that. I actually was looking at a Patreon item here just a second ago, but let's go to office hours. So I have, there's a little bit of an, oh, that's an old one. Yeah, let's just take a look at it anyways. I have this person outside of this, but the, so you guys should see that. Yes, I have a Foxeer Reaper all-in-one V3, and anytime I blip the throttle over 50%, the quad falls out of the sky. Every time the throttle gets about 50%, motor 2 goes to 100%. I've included a picture of the black box log and a debug mode. I've reflashed Betaflight 4.3 and also Flash 4.4. I've updated the ESCs to Blue Jay. I've also changed out a couple of the motors that were a bit rough sounding, including motor 2, but does not change the behavior. Any ideas what is going on? So let's just take a look at the log. It would be helpful in these kind of scenarios to have the full log, because then I could see some stuff in regard. But let's see what we can peel out of this. So you can see we have the motors down here. This is the debug mode is here. So that's these values here. And The top one looks like pitch roll. It's all in the roll, gyro, set point tracking. Okay, so just roll stuff. So what's happening here is motor. I'm gonna go with that. I think that's motor 2. I'd have to. I don't have them. The color. We don't have the legend over here to color code and memorize that. But we'll say that that's motor 2. That's what he was describing there. And when he's going above 50% throttle, it essentially loses thrust. That is awful weird. If you've changed out the motors and remelted the ESC, what I would do is probably change out the motor. I don't even know if I would do that. The first thing I would probably do is just remelt the signal connections from the to the motors specifically, and then also the signal wire, if there is a signal wire. We don't have, I guess it's an all-in-one. Yeah, Reaper all-in-one V3. So it's a all-in-one stack. So there's no signal wires. So you remelt the connectors from the motors to the ESC. And then I feel like it's an ESC issue, which sucks on an all-in-one. So yeah, that's the only things you can do there. I mean, that motor is losing thrust. So 3 is losing thrust. And that's obviously problematic. Normally you'd see that would be triggered as like a desync. So if it's losing losing the motor position, but usually that happens at 0% throttle, not at going above 50% throttle. So that's an odd one. I've never seen that before, where you go above a certain throttle amount and it just drops out. It could be a desync, I guess. I guess the ESC can lose the orientation of the motor at any given point. And then it just kind of gives up. In BlueJ, there's a DMAG compensation setting. I have to double check. They've changed a lot of things in BlueJ. But if you see a DMAG compensation setting in the ESC firmware, they definitely have, well, they have that in BL Heli 32. I don't know how about BL Heli S. So try that setting if you see anything similar to that. I'd have to double check in BlueJ. But outside of that, not exactly sure. If you'd want to upload the log of that, I could peel back the onion a little bit further. I'd love to see the throttle percent curve, with this at the same time. That would be pretty helpful, but yeah. Let me pull this down. Sunday, blah, blah, blah. What's going on, Brandon? How are you doing? So Imp FPV asks just a short question. Do you treat small, tiny whoops, 2-inch, with a heavy 03, so an air unit, the new GGI, in terms of tuning setting presets the same way as you would a normal tuning whip or tiny whoop, or do you use them differently? So they would be, the answer is kind of yes and no. I would start with the same, but there's some adjustments you're going to want to make, or probably will need to make. So let's open up the configurator here and I'll show you what I'm talking about. This over here. That's exactly what I wanted to do. And then pull this up. So what I would do is I would start with the preset. So I would go into here. I don't want that. I want 4.4. And you have some presets here for whoops. You have different ones, right? Here's mine. Here's another one. The advice would be, the advice downstream of selecting your preset would be the same. It doesn't really matter which preset you select. I'll just use mine just because. So say we're using, I would say that all these settings would be the same. You know, maybe you're turning on all RPM filter. Maybe you're using dynamic idle or not. I don't know if it's that important on a tiny whoop. But we're going to go ahead and pick that. Agree. Agree again. And then we're going to set that. Boy, that's taking a long time. Why are you taking such a long time? What are you doing? Line configuration. Is this the, I know the cloud build was down. Is that what we're seeing a symptom of here? The Blue Jay and BLAS has DMAG high or compensation high as an option. Yeah. Thanks, Brandon. So in that previous advice, I would go ahead and set that DMAG compensation high. What is this going on? Why is this taking so long to apply the preset? Odd. Odd, odd, odd. Okay. So just unplug it. The configurator lockup? I've never had the configurator lockup. That's new. Let's go to here. And task. Let's try that again. Betaflight configurator. What are you doing, buddy? Experimental. No, I don't want experimental. Ah, that's my problem. Ah, I see the issue. I see the issue at hand. I'll take that out. Put this in. So we're actually connected to my flight controller. Obviously, that's problematic. All right. There we go. Helps when you actually connect to a real flight controller. There we go. All right, back to the preset. Whoop. Pick that. And go back. Just turn on RPM filter. Pick. Read. Save and reboot. All right. It's my intent. Yeah, don't destroy my beta flight. It was me. All right, so then we got that. So now we have the preset loaded. Sorry about that. Just my mistake. I was trying to apply a preset on the virtual driver. It doesn't really work too well. Once you're in here, so this has that preset loaded. Some things I would take a look at is just firing up expert mode. Two things you may need to do. And it depends on what you're doing with the whoop. If you're flying acro, angle, how high your rates are, how much you're giving it to it. But you may need to turn up damping some. And if you're hesitant of that because of the D terms that you might get here, what you can also do is turn down tracking a little bit. So it's one or the other. You might need to just increase the damping force, but a way to increase the amount of damping that the quad's going to do without turning up your D gains is just to decrease the pushing it's going to do a little bit. At the same breath, and that's only if you're noticing some bounce back. So if you're not noticing bounce back, you can just leave that alone. Because everything flies well, or semi-decently. The other thing you may need to look at, because it's just a little bit heavier, is just pushing up your master multiplier slider here. Now, I would only do it a point or two at a time, and then I would check, because your D gains are getting a little bit higher here, but it should be okay. Do check your whoop motor temperatures, just feel them at the end. It's kind of a little tricky because they're so small, but give her hell and then make sure the temperatures are okay and you're not having any issues there. But if you have plenty of filtering, which that preset does, we have a decent amount of filtering here, and we do have the if you're using the RPM filter on top of that, you have two dynamic notches, and the low pass filters are fairly low on this. You should have some wiggle room to move, again, this master multiplier up. That is probably the biggest thing that's going to help increase performance in general, which is true all the time. Pushing up that master is kind of like the performance increaser. These other ones are just if you need to tune something specifically out that you're having an issue like bounce back or wobbles or things like that. That's when you get into screwing around with these ones. If you just want to increase performance, you're trying to get this pushed over to the right as much as you can without having motors too hot or bad tendencies where it's fluttery or things like that. All right. All right, John. Goblin asks, hey, I'm trying to tune a 7-inch and was wondering if I could get some general tips on which way I should be moving the sliders. In general, would I be moving the D slider or PI slider more? So, same kind of advice on a 7-inch. The biggest thing for a 7-inch is to, let's just go into here, 7-inch, and then go into this one. So the biggest advice for a 7-inch is this stuff down here. Pay attention to this. Tuning a 6-7 inch. This is the gram range I'm typically seeing. In my experience with this is if you want to, for the best performance on a 7-inch, you definitely want to try a lower PWM frequency. So 24 kilohertz, or you can do 24 when you have if it's a BL Heli 32, you can do 24 low and by RPM high. That generally is going to keep it at 24. Many times I just run 24, 24. I don't see aliasing issues. If you have mid-throttle oscillations where it's starting to shake a little bit during smooth forward flight, most of the time just changing the PWM high to by RPM doesn't fix it anyways. That's usually something else that's off balance things or kind of a wonky frame on a 7-inch. 7-inches are hard to get to fly stable and nice and smooth. But definitely for performance, like prop wash performance and having a lot of authority, 24 kilohertz PWM. Now, the second piece of that is these motor recommendations. Or a 6-inch, I would say the minimum is a 25 XX plus motor size. For a 7-inch, it's 28 XX. Now, in some cases, you can do bigger motors. The bigger the motors are down here that you're putting on your 6 or 7 or 8-inch, the less this PWM frequency will be important. So then you could bump that up to 48K. If you are battling smoothness, and it's not so much like the flight performance is good, and in some cases people are using 7-inches just for cruising. Well, if you're just cruising around, you're not caring about prop wash performance, you don't have wobble issues or things like that, then the difference between 24 kilohertz or 48 kilohertz doesn't really matter as much. But if you're having like wobbly issues or prop wash, trying to get prop wash a little bit better, that's where this getting down to 24 kilohertz will matter a little bit more versus the 48. And again, the bigger the motor size. So generally what's the cause of this is that most of the time our 7-inch, the builds that folks are struggling with were 7-inches, just they're under motored. They don't have enough motor power, and the props are pretty heavy for a 7-inch. The moment of inertia for that 3-bladed prop or 2-bladed prop is pretty good, and so you need a decent powerful motor to be able to spin that up and spool that down pretty quickly. So that's where the motor stuff matters. And I've spent a lot of time on this subject, just looking at this right now on this live stream, because it's that important. People skip this and then they just want to make the sliders do magic for them, and you can only go so far with a slider. They're not. This stuff actually increases physical torque, braking torque, or increases, obviously a bigger motor increases physical torque for increasing and slowing down the motors. So that's a physical property that actually you get more force. Changing sliders doesn't give more force. It just changes kind of the timing of things. So that's the first thing. Pay close attention to those details. So let's apply a tune here. Usually would do minimum. See that for, if you hopefully can, have the 16 or 24 kilohertz PWM. I would probably settle on 24. 16, you want to give it a try, but I would get 24. Focus most of your attention there, and then if you want to give 16 a shot for the lower PWM in the BL Heli settings, that's fine. And then I would turn on dynamic idle. If you have RPM filtering enabled for a 7-inch, dynamic idle will make a difference. So yeah, I would check that on personally. So we'll go ahead and apply that one this time and hit save and reboot. Hopefully it doesn't palm out. All right. And then going into the tuning here, again, now generally, let's see if you have anything, if you have any specific symmetry, but the dynamic idle was too high for my quad. So if the dynamic idle is too high, see if you have other issues. I could fly away, it was just high altitude at 0 throttle. Relatively stiff, but it's lightweight, 6-inch millimeter arms. Yeah. So for if the dynamic idle value was too high, just bring this down. Just instead of 3,500 RPMs for you know, the minimum RPM that will spin. Sounds like you have a pretty lightweight 7-inch. See if you have a weight up there. You didn't list a weight yet. I see. No. If you have a pretty lightweight one, you might need to bring that dynamic idle down. Just be cautioned in that as you're bringing this down to 30 or even lower, you know, just be cautioned that you probably want to do some low altitude flips and rolls, you know, over some soft grass, maybe even over some meadow. If you have an area that has some like meadowy weeds or whatnot, you can just go out there and just do some line of sight. You know, if you're going to bring this down, do some line of sight flips and rolls. Do a bunch left to right, right to left, forward, backward. Keep in mind when you're doing those, the motors tend to heat up quite a bit because you're spinning up the motors a lot. But I would do those just to make sure you don't have a desync, because if you get too low on this value here, you can cause the quadcopter to desync, and obviously you don't want to do that in the air. And obviously if you're over a nice flat meadow, you're unlikely to break any of those nice, fairly expensive, not that bad, but 7-inch props. You don't want to break those things. They're not too bad. 10-inch props are the ones that are getting a little costly. Yeah, 900 grams. So that's not very heavy with the 1300 kV motors. So yeah, you can bring that down. In the preset to if you have any specific issues, you kind of get into, you know, adjusting these sliders up here or trying to, you know, anything from other than the master multiplier. These are for specific issues. So if you have, you know, if it's wobbly, which is fairly common for a 7-inch, you kind of, you know, get off the throttle and it's like, first advice goes back to that initial KV or the PWM frequency stuff, the 24 versus the 48. Get those down as low as possible. Motor size, again, get those down as low as or up as high as you're comfortable with. And then, but if you're still having wobbly issues, that's where you would lower your drift wobble slider maybe even a little bit more. So I've seen them having to come down to like 0.4 if you have that specific issue. So it's, if you move the slider, if you have, you know, if you move the slider this way on this one, you're going to tend to be a little bit more drifty. That's kind of for racing. I can't imagine I mean, you could be racing a 7-inch, who knows? If you move the slider too much to the right, then it will tend to be a little bit more wobbly. So that's kind of that balance there. If you have an overshoot, you shouldn't with these settings, but if you are having some overshoot issues, don't hesitate to move up the damping a little bit. Again, it's like I talked about before, if you don't want to move up damping because these D gains do get a little higher, then you can alternatively move down the trackings. Either one, doesn't matter. That's, again, if you're having bounce back, overshoot. If you want it to feel a little tighter on the sticks, move up your stick response. If that's fine, then leave it. If you want prop wash performance to be better, move up the master multiplier. If you want just general stiffer, better performance, that's what this master multiplier is. It's like kind of the performance slider here. Move this to the right, you get better performance. Move it to the left, get worse performance. There is a limit to this. It will eventually, you know, these D gains you can see move up. Basically these D gains are the ones that are the limiting factors for your tunes. So you just keep an eye on those and kind of get a gauge in your mind of what they're at, like the 70s, 80s. Heavier quads, these need to be higher. lighter quads, these need to be lower. So it's finding that balance. If you get too higher D gains, your motors get hot, or you'll start to hear the motors flutter. It'll go like when you arm it, and then you know you've gone too far and you need to bring it back down. So, yeah, hopefully that helped. Check. Any other questions in here? Yep, no problem, John Goblin, for that help. We've got a super chat. I guess we'll address that right off the bat. Michael, thanks for the super chat. Having a major issue with yaw jump on my X-Class build. It jumps. Yeah, I'll go with that's a major issue. Let me switch over to here. It goes, John's saying it goes 20 to 30 feet. I've tried bringing my yaw rate to 300, but even that doesn't help. Any insight would be appreciated. So, yaw jump. I'm trying to remember back. I did a video on yaw jump. So we do have that, and let me go back into that. I'm trying to do this kind of for me more than for you, because I'll go through the specific things. But yeah. Yeah, I think so too, Brandon. So yaw jump is essentially an issue. So I did a whole thing on yaw jump here, but let's try to hit the Cliff's Notes of this. And I would check this one out as well, just to see if it was a while ago, 8 months ago. So I'm trying to make sure I hit all the topics in that I covered in that one. So let's go into here. So yaw jump generally is an issue with the motors not being able to spin up as fast as they can spin down. And it's kind of like an air mode piece of it as well. So let's just say you're at 30% throttle for a hover throttle, which for an X class it's pretty reasonable unless you really have a lot of weight on this thing, unless it's a payload X class. But if it's just a simple X class, they're usually pretty light compared to the disc area that they're creating all that thrust. So when you do a yaw move, you are going to spin up, and I wish I had that log. I do have that log. Let me see here. See if I can really nip this well. Since it was so 8 months ago, we're reducing yaw jump. Let me just view on my server here. But essentially what's going to happen is if you're 30% throttle, well, then that means your motors can spin up. There's two motors spin up for yaw move and two motors spin down. Depends which way you're doing the yaw move. But we know the two motors are spinning clockwise, two motors are spinning counterclockwise. That cancels each other out. When you kick into a yaw move, two of them spin up, the others two spin down. It's not a thrust vector, so it's just kind of a moment of inertia and drag motion that is kicking the quad into yaw. And at the same time, I'm looking for this. So that was 2022. And so what happens is you can spin. Oh, look at that. I found it. Yes. Perfect. So what happens is when you're 30% throttle, obviously two of those motors can spin up by 70% until they max out. But the other two can only spin down by 30% because then they'll be not even. They'll spin down by like 25%, something like that. Because they're at 30%, they can only spin down to 25%. But the other two motors, they could spin up by 70%. So and the motors that are spinning up by 70% are causing more downward thrust. And that's where you're getting that jump in altitude, because it doesn't, the altitude, it's not like the PID controller can adjust for altitude jump. It just reads, the yaw movement itself, but it has no idea how much it's jumping in altitude. It would be interesting, you know, it's kind of a feature. It'd be interesting to have a piece in the PID controller that we could turn on. The problem is the stuff is so slow, but that it could actually, here, it shows it right here. So let's show it. Let me get that there, make sure I'm showing here. So this was just a simple quad movement. Let's simplify this a little bit. So you can see on here, I have, you can see my sticks up here. So this is roll, pitch. I'm going to turn those off just to simplify that. And again, you can see my sticks up here. So now we're just looking at the yaw axis, and there's a whole bunch of terms in here, but let's get rid of the individual terms. I might go back to that, but for now, let's just get rid of those. And you can see here's my green is my stick input, and my gyro, this is what the actual quad movement is this cyan line. And you can see what happens here. So yeah, the two motors that spin down, you know, we're at, I don't know, yeah, 30%-ish throttle. It varies a little bit here. But these are only spinning down by, you know, they're going from 30 down to 0-ish, 0.2%. And then these other ones are spinning way up. So that these are causing additional downward thrust. So they're almost spinning up to 100% throttle. Well, to keep the same altitude, these can't vary from each other. You can't have, you know, 30% less in throttle on two of the motors, but then a 50% increase on other two. They have to equalize out, and they don't. And that's mostly due to air mode. So one thing you can do to help, but I don't know if I doubt you'll want to, but you could do it, is you could turn off air mode and use idle up. So air mode is a big culprit of that imbalance of it jumping up. Just that's the fundamental how air mode works. So you could turn that off, but make sure you implement idle up, because when you go to, if you just uncheck air mode and save this, when you go to 0 throttle, you have 0 control. And for the next class, that wouldn't be good. So you'd have to just look up a video on how to implement idle up. You can do it in your transmitter. It's typically the easiest way to do it. So that's one way to do it. Another way to do it is to go into the iTerm relax right here. And I'm mentioning the most effective way to the least effective way. So turning off air mode will be a very effective way. Now, you might not like the other flight characteristics of turning off air mode, but it will help the most with yaw jump. The other way to do it is to go into iTerm relax and add the yaw term here as well. So roll, pitch, and yaw. What that will do is when you kick into a yaw move, it will be essentially less effective. You're going to get more gap here, where the quad's not going to so tightly follow your stick inputs. So it essentially is going to result in lowering the rate even more. So try out those two different things. I guess the roll, pitch, yaw for iTerm relax is probably the easiest one. You don't have to like figure out idle up. Just set that, hit save, and go check that one out. See what you think about that. But I would definitely recommend trying out air mode. Having things on that will help around the edges, very much the edges though, is dynamic idle will help a little bit. Very minor. You probably won't even notice it, but it won't hurt. It will help spin motors down a little faster, so it help with a little bit of the thrust that you're creating there. And the other thing is, again, just lower PWM frequency on your motors will also help them have some more braking torque. So hopefully that helped kind of understand the issue, what's really at hand, and what's causing it. The biggest cause is this imbalance between, but this it's tricky because this imbalance is what's making this actually track this well. This is tracking pretty good for a yaw move, for no thrust. There's no thrust making this happen. It's just a moment of inertia and prop drag. But on an X class, that's making a lot of downward thrust. So you're gonna have to give that up. Obviously, reducing your yaw rate will help as well. Kind of a tough problem to lick. You have to give something up to make it better. And mostly what you're definitely going to be giving up is implementing how quick your yaw rates can be. Either you're going to reduce your yaw rate in your inputs like you already did even further, or you're going to implement some of these other things which will essentially do it for you, but ultimately you can't give as much yaw input. And there's no way to, you got to get that. There's no way to really make that better that I can think of. It's just too fast of a yaw move that it's pushing these up. Hopefully you can understand why these other things will cause your yaw movements to be slower. So instead of reducing your yaw rate, it just results in a reduced yaw rate. That's kind of what I mean by that. Sunday tuning hour, FPV giggles. It's one of my favorites. Yeah, thanks, FPV giggles. He says Sunday tuning hour is one of his favorite things ever. Help people make, hopefully this helps. Appreciate you guys coming out. Give me somebody to talk to at least, right? So let me see here. I'll jump a motor spin. Yeah, increasing the, Brandon says about increasing the, let me pull this back up here again. Brandon says about increasing the yaw PID sum limit. That's another thing you can look at. It's all kind of getting to the same thing. Get PID sum. So there's also this variable here. This is what Brandon's talking about. If you type in get sum, okay, it took me a second here to remember that. Just type in get sum at the CLI. There is this PID sum limit for yaw. If you move this down, that will essentially it will handicap how much push the PID sum will do, or the PID controller will do on yaw specifically. It's kind of the same thing of what, but that will do it for all cases, all the time, no matter what. That is kind of basically what this is doing for roll, pitch, and yaw. Because this is essentially when you implement a sharp stick move, it is locking I-term. So if I go back into here quick, go back to here, and just take these two off for simplicity. When you're putting the this I-term relax to roll, it's usually on roll and pitch. If you add yaw to it, what that's doing is it's essentially this term right here, the I-term, it's going to lock that during a sharp input. So see where this is raising? You know, all three of these terms add to the PID sum, right? You add pitch, you add, you add negative 8 point, well, these are all negative because it's going to the right. So you add 8.3, you add 6.7, you add all these up, the different terms. That equals your PID sum, hence the sum. And that's what goes out to the mixer. If you set that I-term relax to roll, pitch, and yaw, it essentially locks this term through your stick input. So it would lock it from here to here. to like those 2 points, it would lock this I term from building. And that's what that will do, which will ultimately result in a lower PID sum. And if you have a lower PID sum, then these motors won't push as hard. We talked about the other ways to do that as well, turning off anti-gravity or air mode, things like that. All right. Back to here. So Glorious Quad says the ICM gyro noise issue is frustrating him. Whatever, whenever he increases throttle mid mid flight, it wobbles. Increasing installed latest 4.4 commit, and it helped, but it's still a bit. What can else be done? So this is the ICM 4,000 some odd gyro series. I specifically think you're talking about. There's like a specific ICM gyro out there that's has specific issues, I guess. Um, how can you make that better? Hmm. You can lower your filters, but it's not gonna get totally better. Um, get a different gyro. I, what happens with these gyros that's kind of really tricky is that the the band, like the low end noise floor of them is too high, and you can't just settings that out of that. That's just inherent in its how it's working, and you can really beat your head against the wall trying to use the software to get rid of it, but ultimately it's just a gyro problem. So I would look. I guess I don't have anything on here. Let's look here. I don't think I have. Yeah, this doesn't have. If there's anything else in here that's useful in this regard, but BB3. See if I have any other logs. BMI versus 270 here. Let's go to here. I have something. I have something of value. I hope. Let's see here. Go to here. Yeah, this should throw some value. So what I would do specifically is I would look at the gyro itself. And when you are, this is the BMI 270, not the ICM, but ICMs are kind of the same. This is the raw noise on a 5-inch quad now. And this is a good 5-inch quad. But you can see this is it's not a, I mean, I was getting, yeah, there was a lot of, so this is not a full flight. But this can give you a sense, and I can tell by some of the stick moves I'm doing up here. Essentially, you want to see something similar to this. I would say ignore this part. Anything above like 200, ignore this over here. You want to see something like this in this range right here, where the noise floor of your gyro is pretty low, right in this area, anywhere from like 50 hertz to like 150 or 100. It depends. If it's a 7-inch quad, it's going to be more down like to 100 hertz. If it's a 5-inch, should be like around 150, 200. But this area needs to be low. If that area is not just naturally low in the noise floor, You can't just software that out of it. You'd have to move. I mean, you can try. Um, the best thing you can try is just take these filter sliders and move these down, specifically the gyro one, and you can get these down into this range. I would say once you get down below a 0.25, you're kind of pushing it. But you can try doing that. It doesn't cost anything to do that. It's very easy. Give that a shot. But ultimately, this noise floor needs to look something like that. If not, you need to look at mechanical things, and maybe it's just your gyro, if that's a specific one. Can we cut Fab's tube asks, can we cut absolute control? I don't know. I don't know anybody really uses absolute control. That's an interesting concept to use absolute control. I mean, absolute control is essentially iTerm. It's a faster operating iTerm. I think pilots that the rare amount of pilots that use Betaflight for line of sight, and they're doing a lot of like yaw rotations at the same time they're doing everything else. I think they use absolute control. I know that's the person that put it into Betaflight. That's what his flying style was, and that's what he did it for. So Brandon's saying the Happy model is going back to the BMI 270 after trying the ICMs. Now Diatone is advertising new flight controllers with the MPU 6000 again. This gyro thing is crazy. Yeah. So I don't know if y'all caught that, but I know I know in the Betaflight like dev channel Slack, some guys were talking about that the MPU 6000 is coming back. Like that's being remanufactured again. So between me, the best gyros I've ever seen operate are the BMI 270 specifically. The BMI, the Bosch 160 was, yeah, it has this noise spike thing up at like 900 hertz. But the stuff, from like 50 to 150 hertz was pretty good. So it was pretty good. I would say if I had to pick between the BMI 270 and the ICM, or the BMI 160, the Bosch BMI 160, and an ICM gyro, I wouldn't be hesitant to go with the 160. The ICMs work generally like the older ICM series. I can't remember in my head right now. But as of today, all the testing I've done, the two best gyros that you can get are the MPU 6000 or the Bosch BMI 270. Those are the two. Those are the two to look for. Not saying the ICMs are like the classic ICMs are garbage. I think they're fine. They're okay, but they're not the best. The other two showed specifically increases in this noise or decreases in this noise floor right here. So when put up against each other, and I did a bunch of videos on that stuff. You can just go to YouTube and look up UAV Tech BMI versus ICM versus. I did a bunch of stuff on that. But yeah, those produce the best results. Yeah, try the filter thing. Glorious quads and see if that helps. Just slide those sliders down. The other thing you can do, go back to that quick since I kind of. The other thing you can do is just you can drop these mins down as well. So between dropping the gyro slider here and then dropping these mins, don't get too crazy with dropping these mins down too low. This one you can probably go a little bit farther. This one you could probably go down to 50. And the reason I say for this, I'm sorry, reverse that. This one you can probably go down to 50 because this has a crossfade component where the RPM filters actually start to fade out 50 hertz above whatever this setting is. So by the time they get to this setting, they're not on it anymore. So you can get this one a little bit lower. But you could drop this down. I've dropped this down to as low as like 70. I think once you start getting around 65 and stuff, it gets a little. But you can try it. Just be cautious. Don't. With any of these adjustments that you're trying to do and kind of go outside the norms and drop these things down and drop these settings down a little bit more aggressively, don't like hand launch the drone, or don't say, I'm going to try it and like look above, like have the drone underneath you and look up at it and arm it. Like step back, give it a shot. It's going to be fine. When I do, there's a couple videos. There's one video I did where I was trying to show how high you could move the master slider up. And for that one, I specifically went in the woods. So if the thing, jumped up into the air and started going crazy, which I was right on the disarm, so I wasn't too worried about it. But if you have like a dense canopy tree, put your quad under that near the trunk, back way up. It's not going to fly away because it will hit the tree. So that's, you can mitigate risks in various ways. Yeah, like the ICM 2602, yeah, it is a fine. Like that's what I was kind of saying. The classic ICM gyros, the 2602. I even found the 20. What was it, the 689 was okay. I didn't see any specific. People used to say the durability wasn't there. I never had any issues with it, but yeah, the 2602s, they're fine. Just getting a little nitpicky between those and some of the other runs. The other ones, produced a little bit better results than the ICM series. The like I said, the Bosch 270 and the MPU 6000. All right, so let's. I don't see any other questions here. Let's go back. I did download some stuff. Let me see here. Let's see if I can pull that up a while. All right, so we have a log here. Let's go to here. All right, hello. I'm increasing feed forward, increasing rate to 900 degrees per second. I use more aggressive filtering. Please, any advice helped? Namely, 1, more or less feed forward. 2, de-oscillation is okay. Why there are those oscillations? Should I be more aggressive with the master slider? Link of the thing is here. So I'm just looking at some other stuff. All right, so we have this log. Let's pull this puppy up. This is here. Let's take a look-see. So we got 2 things here. I'm going to go to this one here. It looks like that's the actual full flight. What I do is just go to the, try to use these up here. So it's the UAV Tech. If you're new to here, UAV Tech trace templates are here. If you go to theuavtech.com/black box, there's a video there on the trace templates. They can be downloaded there as well. So I'll be using these here. Shows you how to download them, shows you how to add them to your Black Box Explorer, which is you just open this dialog, which is awfully confusing. This open dialog is like for everything. You want to open a log, you hit open. You want to open a video to have background, you hit here for open. You want to open a template, you hit open up here, which seems simpler, but I thought it was always more confusing. So if there were separate buttons, I thought that was simpler. But anyways, that's how you get that stuff. So we're going to go to noise plots. I can see right off the bat this thing is running good. You can just look down here at the D term. Whoop, go this way. See the D term down here? I'm again on noise plot 0, and I don't see a lot of vibrations here at all. I don't really see that going crazy at all. So that's looking nice. You can also see I don't even have to run the spectrum analysis. See how this is the raw gyro traces behind the like the stick inputs. Like there's 3 things overlapped, right? You have the raw gyro noise, then it's the filtered gyro noise. Looking up here at this one, raw, filtered, and then this is my stick inputs. So basically the stick inputs are here. These 2 things are trying to follow this green line, and you can see, yeah, there's just not very much there. But just to see what I'm talking about, like might help with that previous comment, because this is a full flight. Go to here. This is what a And let's see, what's flight controller is this? I don't really know. Nazgul 5. So I don't know what a Nazgul 5 is using. Oh, this is using a BMI, so you can T down here. So this is using a Bosch BMI gyro. I don't know which one. But this is what you should be seeing for this lower band of noise down here. And this is the raw. This is unfiltered. So you can see that's really good. Like zero filtering on this. And looking at the entire flight for vibrations, and this is all that he's getting on that. So really clean quad, really good build. You can tell a lot by looking at this. I use this as like my build indicator. I don't care, you know, I used to get in back and forth with people about different things, and they would, you know, I'd have on my videos, I'd show my quads, and they'd be like, ah, your soldering sucks. I'll be like, it doesn't really matter. When your logs look like this, you're good. But this is like the end all be all. Low vibration means good flight performance. So if you want to check how well you're doing on a build or with a product, just go look at your raw noise. So anyways, that's looking sharp. I'm going to go to then the trace template number 4. It's going to be stick inputs. So this overlays and kind of looks at and breaks out more of the different terms here. So specifically wanted to know about feed forward. So let's look at stick response. Feed forward is, when we're looking at here, that's this term, this stick response slider. You can see feed forward FF gain right here. That's these gains right here. So he's wanting to know if his gains can go higher, lower. How does it feel? Obviously, that's a big feel piece of it. The intent of feed forward is to help the quad follow your rates. So that's the name of the game. Does the quad, you know, pick rates that you like or are going to get, you decide you're going to get used to, and then trying to get your quad to follow those, because, and get all your quads to follow those. So that's the other piece of this. Now each quad might feel a little different because of the weight, so it throws differently and things like that. Has more mass going into turns if you're racing. But ultimately you have certain rates, and the closer you can get the quad to following those rates, the better you will be for consistent stick feel. To gauge feed forward of how well or good feed forward is, or how, you know, should you add more or less, you're really looking at the P term in relation to sharp stick inputs. So without feed forward, because that used to not, you know, if I go to here, you look at a standard PID controller for like valves and other things in other industries. Like, we're not the only one that use PIDs. There is no, well, there is in standard feed forward. There is a standard feed forward component in like tank design for valves and things like that, where they'll use feed forward. For example, like if you have a liquid going from one tank to another, put a temperature gauge on the line going from one tank to another, and that's your feed forward. So you can read the temperature of the liquid, and then you can start to preheat the water in the new tank to keep the same consistent temperature. So you can, that's kind of that feed forward signal. You're getting some information in advance of when the said thing needs to occur. And that's kind of what feed forward does in Betaflight. It is getting the amplitude of how fast you're moving the sticks right from your stick inputs. It's not waiting for anything. As soon as you make a stick move, that goes across transmitter to the flight controller. It reads and it gets the magnitude of how fast. It's judging how fast you're moving the sticks. If you move the sticks real slow, feed forward magnitude doesn't really move at all. It hardly goes up. If you move the sticks really sharp and fast, the feed forward magnitude will spike. How high it will spike is dependent on these gains. The higher these gains, the more it will spike up. Lower the gains, lower it will spike up. So you can see in here, if we just look, this is a sharp roll move, and we have all our components here. The feed forward gains shown down here are spiking up to his sharp stick inputs. Can he go more? The answer is yes. How do I know that? Because the P term is still kicking in to push. See the gap between these two lines here? That's what the P term is measuring. It's measuring the distance between the green line and the cyan line, and then it's gaining its magnet and it's bumping up its magnitude based on those two things. So the intent of feed forward is I don't need to wait for this error to occur between where what I'm commanding the quad to do versus what the quad is doing, and then start to push it. That's what the P term does. Feed forward, the intent is I can see it, the sticks are moving really fast. I'm going to start pushing in that direction. I'm not gonna wait for any error to occur. Well, how you can know if you can push a little bit more and feed forward is, I guess the ideal, it doesn't really matter all that much, is you don't have a gap here. And if you don't have a gap here, that means this P term won't go up at all. So the ideal feed forward is that you make a sharp input and your P term hardly grows. That means you hardly have pit error. That means your quad is essentially following your rates, if it's ideal, perfectly. You won't ever get to the perfect ideal scenario because your motors aren't big enough. You can't produce enough thrust. The quad has obviously a lightweight. You probably see it more and more if people drop off having GoPros and they're just using the O3 air units, for example. It's going to be a lot lighter. It's like giving power back to your motors for, they're not exactly free. Those O3 air units are pretty expensive, but it's, you'll see your quads have more power. The biggest part where you'll get issues is on this side, and here he didn't have a very consistent drop back. But this side is really tough to get it to follow the stick movement down just because of expo. The more expo you have, the more gapping you'll get over here. That's how you tell on that one. We can look on the same side. It's pretty good though, I gotta say. It's not like he's, you can see what he has here for feed forward. He's like 218, 227, 218. Yeah, you could probably move it up a point or two, would be fine. How you know you've gone too far is if you start to see this P term go the other direction. That means your quad is exceeding your input, your max input rate, which, I mean, it happens all the time. And then P comes in to balance it out. So it's actually your quad's spinning faster than what you're commanding it to. So here you can see feed forward, yeah, could go up a little bit. But on the flip side of this is all feel thing. So if he's like, nah, it feels fine, feels good, I like how it feels, don't mess with it. You can see that, during normal flight and these little, he's moving the sticks here left and right. You can see it up here. That it's not, feed forward is not really doing much there. It's not growing or sinking, but he's really close under the sticks there, so it's pretty good. But yeah, you could add a little bit more. It won't hurt anything. Let's go back to here. Let's go back to this question. And then I guess so I would say, yeah, a little bit more feed forward. He's at, I'll go up, you just go up on the slider a couple points. When I say a point, I mean, I call this like, see where it says 1.34. So I'd say like, you could go to 0.4 or even 0.55, the 10th place. Just move that up a little bit. The other question was D-turn oscillation. Okay, yeah, I wouldn't worry about those. Your quad is completely fine. There's no these little vibration-y things that you see down here. Those are for basically it's the notch filters trying to catch up. They're a little bit behind, or the RPM filters. So your motor traces are fine. I would not worry about these little vibrations or these things like this. I wouldn't worry about those at all. Yeah, like these. I wouldn't worry about those. Those aren't D-term oscillation. D-term oscillation will be more sinusoidal. These are just vibrations getting through. In this scenario here, you're dropping the throttle to 0. The motors theoretically are spinning all the way down. Your RPM filters, your dynamic notches, they hit up against the minimums. And then if there's like a spike of vibration, they'd have to like spin back up, and it can be they're a little lagged. Even the RPM filters are a little lagged because that signal has to get from the motor through the ESC back to the flight controller. Then the notch needs to move. That all takes milliseconds, but it takes milliseconds, and in computer world, that's computers work in microseconds, so milliseconds is a really long time. All right. All right. I think that's it. I think we addressed everything on there. And we are past the hour. Oh, last question he had was, can you get more aggressive on the master multiplier? Yes. Yeah. So that's really his link to these D terms. Yeah, definitely. I think you could probably move this. If I bet you on this quad, you'd be able to move this master multiplier up. I can see you have D maxes here. I bet you'd be able to get these, when you move the master up, all these are going to go up. These will probably get to be up in the 60s. I bet you could get these up into the mid 50s or even maybe slightly above the mid 50s. And then these will just go up proportionately to wherever. I bet you could get up to that zone on here and still be fine. So check it out. There's just move them up one point at a time. Again, be cautious about it because once you get too far, when you arm it, you'll hear it be like fluttery on the ground, and then you know like okay, I've got to. That's kind of the limit. That and a little bit more feed forward, and I don't see any bounce back or anything. I'd say this thing is basically tuned as well as it's going to be. Yeah. So okay, well, 6 after the hour. I want to thank everybody for coming on out, and hopefully we've addressed your questions. If you guys have follow-up questions that I didn't get and I didn't see here or anything, I didn't see anybody tag me now on any of the stuff in the Discord. Don't hesitate to hop on the Discord and tag me if you're looking for specific help from myself. I've got 2 young kids and full-time job and busy running around. So if you're really looking to get my attention, the best way is to tag. I do pop in there every now and then and check out. And in the Discord, people are helping each other out a lot as well. So, and there's the Facebook groups and all kinds of stuff. So don't hesitate to reach out for help. I know we're all trying to have a good time doing this thing. But everybody get out there, enjoy your Sunday, and I will see you here on the next one. Thanks, everybody.